All right. Good evening to all the grade 12 students. Welcome back to one more session of your board examination preparation. That's nothing but the last 30 days series. Out of 30 days, we are on the 13th day, students. Nothing to worry. As I said, all the 10 chapters will be covered from my end. So today we are going to do most important chapter, that is nothing but electrochemistry. Yes. So we have started the electrochemistry chapter. In that, I'm going to together in this 100 questions. As I said, in 100 questions, I'm going to cover your 1 mark questions. I'll be covering 2 mark. I'll be covering 3, 5, as well as numericals also. So watch the series on daily basis so that you'll not miss a single question from my end. Yes, 100 questions is our the thing, students. Our target is this. This will cover 100% of your chapter. 100 questions, 100%. Let us not waste time. Let's start the question. Let's read the question carefully. Yes. What does the question say? Calculate E naught cell for the following reaction at 298 Kelvin. Okay, 298 Kelvin. Which reaction is given? There's a reaction which is given that's between aluminium and copper. All right, so I have to calculate E naught cell. Which equation talks about E naught cell, E cell, and everything? Nernst equation. Yes, you said right. Said it right. So Nernst equation. First, we will write Nernst equation. For this Nernst equation, after writing, I'll be getting at least 1 mark for this. So what is Nernst equation? Nernst equation is E cell is equal to E naught cell minus 0.059 by n, right? Divided or log of oxidized part. What is oxidized here? Aluminium is oxidized. So anodic compartment, aluminium. And what is the this one valency, or if I have to test it, the number of atoms balanced? So it is 2 atoms, 2, right? Divided by the reduced part, that's nothing but your copper, right? So copper, Cu plus 2. How much is the balanced? No, this one, the coefficient is 3 here. This is your Nernst equation. Now let us write what are there in the given to me. What are given to me? Given part is given. Did they give me n? No, they've not given me n. See, in this equation, I need e naught cell. E cell is given to me. First, let me write e, right? E cell. How much is e cell value given to me? 1.98. Okay. Is n given to me? N I have to calculate. I'll calculate. How much is the concentration of aluminium given to me? Aluminium given to me is almost, it is 1 into 10 raised to the power of minus 2 molar. How much is the concentration of copper given to me? Copper plus 2 given to me is 1 into 10 raised to the power of minus 2 molar. Is it right? Let us go back. Both are same. 1 into 10 raised to the power of minus 2, 1 into 10 raised to the power of minus. So I have to calculate what, students? N. How to calculate? Write this balancing of electrons. First of all, at anodic compartment, N is nothing but number of electrons, right? So at anodic compartment, what is going to happen? Aluminium, which was a solid, it's going to give me aluminium plus 3 ion along with 3 electrons. Same 3 electrons from anodic compartment, they start going to the cathodic compartment. Perfect. What will cathode do? If a copper is there at cathode, it's going to take only 2 because it requires only 2 electrons, and it's going to form copper solid. But problem here is electrons are not balanced. Here you have 3 electrons, here you have 2 electrons, so I need to balance both of them. So here you are going to multiply with 2, here you're going to multiply with, why should I do that? Because I can cancel the number of electrons, right? Okay. Now you multiply. Once you multiply, you're going to multiply with every atom which is there. First, aluminium multiplied by 2 is 2Al. Okay. Copper multiplied by 3 is 2 copper. 3 copper. This side electrons and this side electrons get cancelled. Gives me how many aluminium on left hand side? Al plus. How many copper on right hand side? Cu. Right, done. Now from here till here, how many total electrons? How many got transferred? Total electrons. Over is over. Now let us substitute in the Nernst equation. Any doubt? Please ask me in the comment section. So let us start substituting. E cell is equal to E naught cell minus 0. I'm again writing the equation, divided by n. Nothing. Log divided by Al plus 3. How many coefficients? How many are there? What number of coefficients are 2? In case of copper plus 2, the coefficients are 3. Right? That is what is the equation, right? Copper coefficients are 3. Done. I wrote it correct. Substitute. E cell is how much, students? 1.9. How much is E naught cell? I need to find out. Next is how many electrons are there? Transferred 6 electrons. What is the concentration of Al? It is 10 raised power of minus 2 and the coefficient is 2. Which is copper? This is also 10 raised power of minus 2 and the coefficient here is 3. Alright, done. Now, so further dividing and doing the equation. So this is A log A by log B. Correct na? So log A by log B. So 2 by 3. When it goes above, what is going to happen? First you take out this E naught cell. You get it out because you need to calculate. E naught cell, I took it outside. Okay. So 1.98. So here 1.98 is out. Alright, let me write 1.98 plus because I changed this plus sign to minus, so I made this minus into plus. So how many electrons? 0.059. Electrons 6. The log, can I write it as 10 raised power of 2? That gets cancelled. Only 10 raised power of 2. Further making it more simpler, can I write it as E naught cell is equal to 1.98 plus 0.059 divided by 6 2 log 10. Can I write it because you're converting it to base 10 because log 10 is 1 only. Log 10 is 1. So I made it more simpler. Then further what will you do? Now you calculate. So E naught cell is equal to 1.8 plus when I solve this part the 0.059 into 2 by 6 when I solve I got and log 10 is anyhow 1 correct. I got when I calculated I got an answer of 0.0197. So all put together E naught cell is equal to 1.999997 volts. This is the answer they asked. Over. Simple. That is what is the question. Do it gradually and understand. I also did a video where I said calculate log without log table. So watch that video. Alright. So before I go to the sum, one more sum is there in this. So this is clear. So I'm again telling you, please watch. Please watch the video which says the title is how to calculate log without log table. Calculate log without log table. This is the video. Please watch that. All the Nernst equations can be done. Next question. Using the E naught values of A and B, predict which is better for coating the surface of iron. Okay, so what did they give me? Here they've given me reduction potential to prevent corrosion. Okay, corrosion means I have to protect the metal from oxidation. Okay. Here, this value A is given, this value B. Everywhere reduction potentials are given. What did they say? First of all, this is your iron metal, correct? I have to protect it. So they asked me whether should I cover it with A or should I cover it with B? This iron. Should I cover it with A? Should I cover it with B? Now let us write the values. For the first element or this iron, how much is the reduction potential? For iron, Fe plus 2 by Fe is, for iron, Fe plus 2 by Fe is how much? Is 0.44. 0.4 volts. Okay. Minus. Then for A not, they give me how much they give me A2 plus by A plus by A plus by A. They've given me the value as much they give me minus 2.37 minus 7. Now volts. E naught E2 plus B, what did they give me? It is point minus point. Okay, easy. Now check student. Check. Concept here is standard. This is standard only, right? This is standard E not standard. Which one? RP or OP? Standard reduction potential. So the standard reduction potential of that particular element, whichever you're selecting, whether it is A or B, it should be less than iron. Should be less than iron. Less than iron. Then what? Why, ma'am? Why it should be less than iron? Then only it will get oxidized. That gets oxidized, iron is protected. Correct, na? That gets oxidized, iron is protected. That means the one which is having lesser reduction potential or standard reduction potential than iron will work best. So this iron here is how much? Minus 0. Tell me among these two Which one is having lesser reduction potential? सबसे कम A वाला, right? That means minus 2.37 volts, that's nothing but A1, will coat iron perfectly. Now, because why? Because this reduction potential is less means it will undergo more oxidation. It undergoes more oxidation faster. What will happen? Only. All right. Now let's start and just go to the next question, students. Let us read this question. What does this question say? Says at 299, 291 Kelvin, rather, the molar conductivities of 291 Kelvin, the molar conductivities of infinite dilution, rather, it is at infinite dilutions of ammonium chloride is given here, sodium hydroxide is given, NaCl are given. All right, respectively. If the molar conductivity of a centi-normal solution of ammonium hydroxide is so much, what is the percentage dissociation? Okay, this is one task for me. One is percentage dissociation of ammonium hydroxide and also calculate dissociation constant. These two are the tasks for me. I need to calculate. For which one? Ammonium hydroxide. First of all, as the question is given to you, first of all, important thing, remember we are going to apply which law? We are going to apply Kohlrausch law. So first of all, what is given to us? Let us write what is given to us. They have given me molar conductivity at infinite dilution of which one? For ammonium chloride. How much is given to me for ammonium chloride? It is 129.8 centimeter square, Siemens centimeter square mole inverse. What is next given? Lambda m for a sodium hydroxide. How much is this given to me? It is 217.4 Siemens centimeter square mole inverse. Then lambda naught for which one is given to me? This is NaCl. How much is this given to me? 108.9 Siemens centimeter square mole. This is done. So what did they ask me? They've asked me for ammonium hydroxide. So now I'm going to apply. So I'm using Kohlrausch law. By Kohlrausch law, how do we write ammonium hydroxide? Kohlrausch law, it says that it depends upon or lambda naught conductivity infinite dilution. For ammonium hydroxide, it depends upon the individual ions, correct? Na? Right? What is this equal to? To NH4 plus OH minus. Done? All right. Now, they asked me to find out what, students? They asked me to find out percentage composition. First of all, we have what we have with me: ammonium chloride, sodium hydroxide, and NaCl. Now, only see. I'm going to write. I'm going to start solving. First of all, lambda naught infinity for all the three. What will I do? I'm going to take, because I have to calculate for sodium hydroxide, so ammonium hydroxide. First of all, I'm going to take first one. What is that? First one is ammonium chloride. Now I'm adding ammonium chloride. Then again, next I'm adding sodium hydroxide. Then I'm subtracting from this sodium chloride. Ma'am, why? See here. I want ammonium hydroxide. Here, this plus and this minus gets cancelled over. Here, positive Na and negative Na gets cancelled over. What is left out? Only sodium hydroxide. Ammonium hydroxide is left. Perfect. Now write the values. First one, ammonium hydroxide is 129.8. Next, sodium hydroxide was 217.4. Sodium chloride is 108.9. Okay, done. There's a value 7 centimeter square mole in 1. When I get this, I get the molar conductivity for ammonium hydroxide. If I like, this one for at infinite dilution, I get around 238 point. Okay, this is for your ammonium hydroxide. So, for students, now what did they give me? They have also given limiting molar conductivity. They've given me centinormal. Okay, 9.3. Okay. They said if the molar conductivity of centi-normal solution of ammonium hydroxide, centi-normal, like the molar conductivity of centi-normal solution given to me is centi-normal is this one, 9.33 Siemens centimeter square mole in. This is also given to me, correct? What should I find out? They have to find out degree of dissociation. First of all, I'm going to find out degree of dissociation. Degree of dissociation. The degree of dissociation is denoted by alpha. What is the formula? Alpha is equal to lambda c by lambda m at, or lambda c by lambda m at infinite dilution. Substitute alpha is equal to how much is given? 9.3. How much is lambda naught I got here? 238.38.3, coming to almost 0.0392. Now, percentage dissociation. So, what is this percentage dissociation? Nothing. Whatever degree of dissociation you got, right? If you multiply this degree of dissociation with your percentage, it becomes percentage dissociation. This comes to 3.92. So, percentage decomposition dissociation. Okay. Now, what did they ask me? They also asked me to calculate dissociation constant. Second one, I'm going to calculate the dissociation constant. Dissociation constant. Okay, how to calculate? For which one? For ammonium hydroxide. Now you tell me ammonium hydroxide dissociates equilibrium, it dissociates, there's an at equilibrium it dissociates further into ions, and both are here forward and the backward reaction. They reach an equilibrium, they attain an equilibrium state. So at the initial concentration of ammonium hydroxide, how much was it? The initial concentration. See, once can I check whether it is getting recorded or not, students? Let me check. Because problem will be if it is not recording, yes, a problem for us. Okay, recording. So I'm just proceeding further. What was the initial concentration of ammonium hydroxide? C. Then this and this was zero because it is initial. Gradually, when it has reached the equilibrium concentration, what is happening? This ammonium hydroxide was, or this part, let us take this part at equilibrium, a part of it got converted into ammonium ion, part of it got converted into hydroxide. That's minus C alpha because from here only it got converted into ions. So can a simple terms can I write into 1 minus alpha? Right. Now write the K formula. What is the K formula, student? Formula is C into C alpha into C alpha by C into 1 minus. When I write this will become C square alpha square by C minus alpha. Correct na? So when I simplify, take out everything, you get a formula of C, cancelling everything, alpha square by 1 minus alpha. Okay? Substitute the values given. Do I have a place? Yes, I have place in next one also. So I'm going to substitute the values. Substituting values. So how much is value for 0.01 molar or normality is equal to 0.01 molar. Okay. Does alpha value is 0.03. Can I substitute in that? Yes, substitute. So K is equal to 0.01 into 0.0392 square divided by 1 minus 0.03. Now, if I simplify, can I write 0.01 as 10 raised to accepted? Can I write 0.92 as 3.9 10 raised to minus? I write this? So 1 minus 0.092, it comes to almost 0.96. When I solved, I already solved it. I got an answer of 1.599 into 10 raised to power of minus 5. Check this answer. You also work out and check this answer. Got it, students? That means, what did they ask me before I go to the next question? They asked me two things. One is percentage. Here we got no, we got percentage dissociation value. So you will end up your answer. Hence, percent dissociation. They asked me percentage dissociation value is 0.92% and the dissociation constant value. Dissociation value, that is K, equal to 1.599 into 10 raised to 5. You can write this, right? Okay. All right. Let us see one more question. Right. This is a beautiful question, easy question. And they've given me a salt bridge. They've given me a galvanic cell. What did they say? Consider the figure below and answer the questions 1 to 6. Okay. Carefully understand this is which cell, anodic half cell, anode. This is which cell, cathodic half cell, or silver. Let us read. Always electrons will flow from anode to cathode. Right? Let us see the question. 6 questions are given. I separated all the 6 questions in a page. I'm taking that page. See the question. Write the direction of flow of electrons. Where it will flow, students? Write the answer. Electrons move from zinc to silver. Correct? Next question. Silver plate, the anode, a cathode. Silver plate is always a cathode. So silver is acts the cathode. So be simple, be clear, and one line is enough. What will happen if salt bridge is removed? I'm removing the salt bridge. What will happen? I remove the salt bridge. Cell will stop functioning because the exchange of ion, because it acts as a permeable membrane, right? So functioning. Cell will stop. There is no salt bridge. There will be mixture of ions from cathode and anode, right? It will stop functioning. Right. The next question. Read the next question rather. Fourth question. When will the cell stop functioning? Simple. Only one line. When E cell value is the cutest cell value is 0, the cell will stop functioning. How will concentration of zinc ions and silver ions be affected when the cell functions? Okay, so cell has started functioning. Zinc ion concentration will be increasing. Initially, zinc ion will be increasing, and copper ion concentration will be, means it is increasing. When I compare, not copper, rather, sorry, silver. Silver ion. There is a, because they have given me silver, I should not copper. The concentration of silver plus ions. In silver, they have given silver pi plus ions will decrease gradually. Next question. How will the concentration of zinc plus 2 ions, silver plus 2 ions affected after the cell becomes dead? Cell becomes dead, what will happen? They're asking. So when the cell is becoming dead, that means cell is equal to 0. Then what will happen? Equilibrium is already reached when that particular E cell is 0. Then concentration of zinc and Ag, there will be not be any change because it has already reached the E cell value. It has reached an equilibrium state. Right? Zinc concentration and silver concentration, whatever is there, concentration, silver concentration will not change. Will not. Understood the question? Let us see the next question. Okay. They've given me one question here. Let's read. Calculate delta R G naught for the reaction. Given me E naught cell value, 1 Faraday value, done. Simple. What is the reaction? First one, I'm calling the first. They have given me magnesium. Okay, so copy the reaction as it is. Magnesium sulfate, okay, plus copper is in aqueous condition. Done. Then it gives me magnesium plus 2 ions. Then it gives me copper solid. This is okay. Done. What should I calculate? I have to calculate delta G naught. Delta R G naught equal to minus NFE cell. Right, students? Done. Let us substitute the values. Substitute the values. Here, what is N? What is the number of electrons transfer copper? 2 electrons. N value is 12. This Faraday. Faraday is 96,500. 3 mole inverse. What is E naught cell value? E naught cell value given to me 71 volts. Substitute delta G naught is equal to minus 2 because NF minus NF E naught cell, right? 2 into 96,500. C mole inverse 2.71 volts. When I multiply, I get an answer. Yes, 520 J mole inverse. I'm further simplifying it, making it minus 523 because I have to get it to the 3 decimal for the answer, right? 523.03 AJ mole. Done. Done. The next question. So delta G naught R value is the direct application question. Let me write. It is a direct application question. Application question. Done. Okay. Let us see the next question. Name the type of cell which was Apollo space program for providing electric power. Oh, okay. Apollo space program is nothing but your fuel cell, right? Yes. So you'll just write in one word: hydrogen oxygen fuel cell. And fuel cell. Perfect. Perfect. So again, students, I'll be doing tomorrow. I'll be meeting you again with some more questions. As of now, off. Watch all the questions, note all the questions. Again, I'll meet you tomorrow with some. What is our target? Our target is electrochemistry in 100 questions. Electrochemistry in 100 questions. So I'm going to fill up all. This will cover all the topics, 100% of your chapter. So like the video, share the video, and subscribe to the channel. Mom will never put you down. Remember. Take care. Bye. Thank you so much.